So what we know is that you're going to react more to the change in the price of gasoline the more things you can adjust over the relevant time horizon. But the key is whether can you adjust more things in a short period of time or more things in a long period of time. That depends on whether things are intertemporal complements or substitutes, whether they're storables or durables. The basic principle that you adjust more when that you change your behavior more when you can adjust more things is called Lish Ateliers principle. And it comes from chemistry. It's the idea that, when there's more things in the chemical system that can adjust, it's able to accommodate more things being dissolved into it. Okay, and this is basically the driving force behind all the analysis of dynamics that we're going to be doing. Supply is more elastic over frames of time when more things can adjust, and the adjustment is always going to be relative to other market opportunities. So for example, think about the house that we were talking about, living in a place. Now, if you could costlessly rent out your house for the same amount that your mortgage is, if it didn't take you looking for people or any of that stuff, then it really wouldn't be that durable living in a city, right? You could live in a city one week, rent out your house the next week, come back, rent it out the next week, and that would be just fine, right? The thing that makes things durable is that you can't freely go to a market to sell the use of that thing for the time. On the other hand, for a storable, if that candy or that champagne you could freely buy in a store or resell to the store, and that wasn't a costly thing to do, then it wouldn't really be storable, right? You could use it when you wanted and not when you didn't, and there would be no reason to think of it as a thing that you need to hold on to, right? So I think in that sense, it's often, though not always, more frequent that storables can be more easily sold back to and gotten from the market, and therefore that there are probably more things that relative to market opportunities are durable, and therefore we're going to focus on durables. Another reason we're going to focus on durables is your textbook basically only discusses durables, and most textbooks only talk about that case and just blithely say that in the long run everything is more elastic than in the short run. But at least you guys are now aware of what that rests on. Okay, so following this, let's define the notion of runs. So what is the short run or long run supply curve? Well, I want to claim that each of these corresponds to what the average supply that a firm will make is over a certain length of time if we have the prices, which might be going up and down over that period of time, uniformly shift up or uniformly shift down. So imagine that the firm is producing for a year, and the prices might go up and down over the course of that year. But something causes those prices to uniformly shift up. The question is, how much will the average production of that firm increase during that period? Right? And the longer the duration or run of the production, the more durables you'll be able to adjust over that time. And therefore, the more elastic your production will be to changes in the price, right? And so when I talk about a run, when I talk about short run or long run, I want you to think of that very literally. Short is a certain period of time. Long is a certain longer period of time. And the run is the duration with which that production endures. So 2-year run means if prices were to shift up by sort of a constant amount for a 2-year period, how much would you change your average production over 2 years? Now, the typical taxonomy that these types of books would give would be that short run, in the short run, that's the time frame when you can adjust variable factors like unskilled labor, raw materials. In the medium term, you can adjust things that are somewhat more fixed, like plant sizes, production methods, etc. And in the long run, you have the entry of new firms and the supply of factors to those markets. So what does that mean? If there's an increase in the demand for a product, it's not just that that firm is going to produce more, but all the people who supply that firm are going to produce more. And maybe more people enter the industry of supplying that firm, those firms that produce those goods, right? Now, all of these things are sort of heuristics, just general rules, and there's lots of counterexamples. So one counterexample to the notion that entry is something that only happens in the long run is, I don't know if anyone followed what happened with Groupon, but Groupon was introduced, and almost within 8 or 9 months, there were already like 100 firms competing with Groupon, right? So everyone would have said, oh, Groupon, they got into the market first. They should have some real advantage. And in fact, a lot of their stockholders thought that was the case and therefore paid something to buy Groupon. But then they all lost their money because everyone came in and competed Groupon basically out of the market, right? Another example, which goes in the opposite direction, is, if you think about the medical industry, it's been booming for this huge amount of time. There's been all this technological innovation. And yet the techniques that are used to deliver medicine to you are largely the same that they were 100 years ago, despite the fact that Groupon's competitors, within a couple of months, all came in, right? And of course, I think that that's to a large extent because of the sort of regulatory environment that's on the medical industry. But what that tells us is that it's not just the nature of the factor that determines things, but the institutional environment in which firms operate, right? And furthermore, we shouldn't just talk about short and long run. We should actually talk about how many years we're discussing here, because that's going to, for different things, matter a lot. Okay, but before we do that, I just want to consider a simple example of Lish Atelier's principle, just so you sort of see how it works. So imagine that we have a production function that the output is x to the 0.4 power times y to the 0.4 power. That's a Cobb-Douglas production function with equal weights, right? Now imagine that both factor prices are equal to 1. Then the total cost for the firm you can compute is going to be 1/2 times O to the 1 over 0.8, because the degree of homogeneity here is 0.8, right? Because if we double both of these, it raises the output to 2 to the 0.8. So we get 2 times output to the 1.25. So that means that marginal cost is 2.5 times output to the 2.25. Now imagine that the price is 2.5, then in the long run equilibrium, then the output is going to be 1 per unit time in the long run, and x and y are both going to be chosen to be 1 to produce that output, right? Okay. Now suppose that y is fixed in the short run. You can't adjust it. So now I want to derive the short run marginal cost curve. Now y is fixed at 1, right? It's fixed at that long run equilibrium. So the short run output function is just output is equal to x to the 0.4. We can't adjust y, right? So that means the total cost is 1, the cost of y, plus the output to the 2.5, right? Because y has now become a fixed cost because we can't adjust it in the short run. The marginal cost is then 2.5 O to the 1.5, taking the derivative of that, right? Okay. So the first thing to note is that the marginal cost curve is much more elastic now in the long run than it was in the short run. So I'll show you that on a graph. So here are these two curves. The long run marginal cost looks like this. The short run marginal cost looks like that. So a firm that has a long run change in price is going to hugely expand output. One that has a short run increase in price will hardly change it at all because it doesn't have the opportunity to change y. Okay. The second thing to note is that at the long-term equilibrium, these are exactly the same. Because y was chosen to be equal to what you would do in the long run, right? So at the equilibrium output, it doesn't matter that y is fixed because it's fixed at the level that you would set it at anyway, right? Okay. This last principle, that the marginal cost at the long run optimum is the same in the short run and in the long run, is called the envelope theorem. If you're choosing something optimally, then it doesn't matter locally to the point where you're choosing it optimally whether you can adjust it or not in terms of how much something's going to cost you. Okay. And we'll see in just a second why this is called the envelope theorem. Okay. And to do that, let's compare the short run and the long run average cost curves. So the long run average cost curve was the one that we already calculated here, right? The total cost is 2 times output to the 1.25 divided by O, which is to the 0.25, right? Now, what is going to be the short run average cost curve? Is Cheng Yi here? Yeah, Cheng Yi. Can you derive the short run average cost curve? Because here are the short run total costs. So how do we derive the short run average costs?
Well, we divide it by O.
Exactly. So what then is the short run average cost?
So it's O to the power 1.5 plus O to the -1.
Exactly. Exactly right. Short run, so short run total cost was just O to the 2.5 divided by Y plus Y. Y is set equal to 1, right? And the short run average cost is O to the 1.5 plus over Y plus Y over O. So the key point is that, which is the envelope theorem, is that if we plug in y equals 1, that's going to be exactly the same thing that we're going to get here if the firm is producing the output that made y equals 1 be optimal. And in particular, that's true for a whole bunch of different values. So if we choose the value of y that is equal, that would be optimal for a price that's right here, then the short run average cost will just touch the long run average cost at that point, at its minimum. And you can see this is sort of like an envelope. It's like tracing out the bottom of it. Okay. So the envelope theorem says two things. The marginal cost is the same at the point where the long run, at the long run optimum. And that comes from the fact that these things are not just touching, but they're tangent at that point. And that's what also gives us the fact that the marginal cost is equal at the long run optimal point. And the second thing is that the series of these curves trace out what the long run average cost is. Okay. This principle, the envelope theorem, shows up tons throughout economics, and we'll use it a bunch during the course. Okay. So I want to again try to interpret all of these things about what happens in the short run and the long run in terms of different duration shifts in the price or the demand for the product. But this raises, I think, some interesting questions. So one is, what is the relationship between the length of time for which a given input lasts and the run in which we should call short run or long run for that industry, right? A second is, for example, what are the short-term reactions to a long-term shift? That's sometimes what you hear people meaning by long run versus short run. Not what would be the reaction to a long-lived shock, but what is the long-term reaction to a permanent shock versus the short-term reaction to a permanent shock. A third thing is, what is the long-term effect of having a bunch of short-term shifts? A fourth is, what if it's unclear how long a long-term shift is going to last? And a fifth is, what does the